Yes, student, in the last video and class, we have seen the bond cleavage possibilities in the alcohols. On the basis of bond cleavage possibilities, we have seen how many type of possible reactions are possible, how many type of reactions are possible with the alcohol. Now, one by one, today I am going to share the possible reactions. The first reaction, okay, due to cleavage of OH bond, that is this bond, okay, shows that alcohols are acidic in nature. Alcohols are acidic in nature. Okay, but can you think that the acidic strength of alcohol is like mineral acids or other organic acids? No. Alcohols are mild acidic. Okay, they are not strong acid, but they are only what? Mild acidic in nature. That is, releases H2 when reacts with highly reactive metals, Okay, now which are the highly reactive metals? The highly reactive metals are, can you tell me the name? This is what? Sodium, potassium, magnesium, aluminium, etc. Okay, alcohols cannot change litmus paper, that is color of litmus paper, while the acetic acid can change, mineral acids can easily change, but alcohols are so weaker acid that they are unable to change the litmus paper. Okay, now as I mentioned here, this shows acidic nature only when reacts with highly reactive metal like sodium, potassium, magnesium and aluminium. So we can write reaction like first one, when reacts with metals, releases hydrogen gas, releases H2 gas. Okay, I will show you, okay, in the practical Na. Okay, forms 2RONA plus H2. That is what? That is cleavage of this bond takes place. Isn't it? Even the reaction is very high in case of primary alcohol. So the order is, that is order of reactivity. is what? 3 degree least reactive, 2 degree more reactive, and the 1 degree is the most reactive. Now what is the reason behind it? Reason, okay, R, O and H. Here the release of H depends on electron density on oxygen. Okay, if the oxygen have less electron density, then can easily release hydrogen, isn't it? Why? If it is electron deficient, whenever it can gain electron of OH bond. But if it will become electron efficient, then it will not show the tendency to gain the bond pair electron. Therefore, the release of H becomes difficult. That means overall we can say release of H depends on electron density, okay, on O atom. How it is? If O is electron deficient, then will attract bond pair electron of which bond? Of OH bond. Okay, of OH bond. In case of tertiary alcohol, case of tertiary alcohol, three numbers of R group, which shows, now think, alkyl group shows which type of nature? Electron withdrawing or electron releasing? So we know that the alkyl radical shows electron releasing nature in case of R group. Okay, and how many numbers? 3 numbers of R group, which shows electron releasing nature. Okay, increases electron density, where? On O atom. So I told you, if there will be increase in electron density on O, then the tendency to gain electron of OH bond will decrease. Getting? And therefore acidic nature will decrease. So electron releasing nature increases electron density on O atom, hence release of H, okay, becomes difficult. Student, actually what? This is the change in high school study and higher secondary school study. Here, not only we have to gain knowledge, but this knowledge must be proved by the specific reason. Whenever it will be useful for board classes and for higher secondary classes. Okay, here not only we have not to say that the alcohol is less acidic in nature. Here we have to prove why the alcohol are less acidic. That is, we have to give proper reason. Again here, the alcohols are classified as primary, secondary and tertiary. So three types of alcohols are there. So which alcohol will be most acidic and which one will be least acidic? So not only we have to say that the 1 degree alcohol is most reactive, but along with what, we must have to give the proper reason, and this reason must be based on a particular concept. What is the particular concept? The particular concept is the presence of other group attached with in the molecule. And what is the nature of that particular group? Student, we know that the alkyl radical, they shows positive inductive effect. Remember, in 11th class we have studied about the different type of effects. So the inductive effect, and which inductive effect? Positive inductive effect. What is the role of positive inductive effect? It increases the electron density on attached atom. So if the attached atom will become more electron efficient, then it will act according to it. That is, it will give its effect. The effect here, particularly we are talking about acidic nature, so it will decrease acidic nature. Student, at least you have to see this explanation 2 to 3 times, because there is chances of confusion. Okay, and this is very new session for you, and therefore you have to pay proper attention so that we can utilize the same concept in the next chapter. Yes, student, the next content is comparison of acidic strength. Okay, student, today I am going to compare comparison with, okay, so what, water and phenol. Water and phenol. Student, the structure of water, phenol and alcohol, okay, are almost same. The difference is only of the bond angle. Otherwise, the structure is same. Like I can write 1 O and H2. This is what? Water. Okay. It has 2 lone pair, 1 and what? 2. Nature is, it is partially positive charge, it is having partially negative charge, and hydrogen is again having partially positive charge. That is dipolar in nature. This bond pair is slightly shifted towards oxygen due to more electronegativity. Okay, I can take one more. Now think about alcohol. This is what? H, and this is R. So what is the change? Besides of H, one side there is what? R. But the nature is again same. What? Having 2 lone pair, in which oxygen is fraction negatively charged, hydrogen is fraction positively charged, and the electron pair is slightly shifted towards oxygen. But there is a change in this R. Okay, there is what? Hydrogen, but there is what? R, that is alkyl radical. Isn't it? And what is the nature of alkyl radical? It is electron releasing group. It behaves like electron releasing group. That is, it shows positive inductive effect. Isn't it? So, if we compare the acidic nature, we can compare by release of H. Release of what? H cation. How it is? After release of H cation, it becomes OH anion plus what? H cation. Getting? That is hydroxide ion. After release of H, okay, it becomes R O anion plus H cation. Isn't it? in alcohol, presence of R group shows which effect? Positive inductive effect. Positive inductive effect which increases electron density on which atom? On O atom. Okay, hence release of H cation becomes difficult, difficult, so is less acidic, okay. This is one of the reason. Second reason is formation of alkoxide ion. Okay, which is highly unstable. Okay, again combine with released H cation. That is what? Here alkoxide ion is what? Highly unstable. Now why it is highly unstable? Look at, in oxygen there is a lone pair with negative charge and R is having what? Electron releasing nature. So already oxygen is unstable. If the alkyl radical will again release electron on oxygen atom, then it will tend to increase its unstability, that is electron efficiency. And if it will become highly electron efficient, then will again combine with the H which is earlier released by the alcohol. That means what? That means the quantity, that is the concentration of H will again decrease. So as there will be decrease in the concentration of H cation, the acidic strength will decrease. That means what? The alcohol is less acidic as compared to the water. Okay. Now in case of water, getting, there is no any such group, okay, which can increase electron density on O atom, because H is already what? Electron efficient. So this H is unable to release electron on O. That means what? That means there is no any such group which can increase electron density on O atom, hence, okay, can release H cation easily. And the second reason is what? Second reason is in OH. Now OH become what? Anion after release of H cation. In OH anion, okay, its stability, okay, remains maintained due to what? Absence of R, that is, now I am writing what? Electron releasing, okay, or this is called plus I effect. Okay, that means there is no such group. Okay, because it is what? Absence. But I told you that today I am going to study about what? Comparison of acidic strength of alcohol with water and phenol. So we have to check one more compound. What? Phenol. What is phenol? Again, there is what? One H and one what? Benzene ring. One what? Benzene ring. Okay. This is benzene ring. Again, there is two lone pair. Oxygen is electron efficient and hydrogen is partially electron deficient. That means the bond pair is shifted towards oxygen. Okay, but what? There is benzene ring. Now, what is the difference between alkyl group and benzene group? Alkyl group shows electron releasing nature, while the benzene group shows electron withdrawing nature. Why? Because benzene is what? Unsaturated. So due to unsaturation, that is the delocalization of electron inside the benzene ring, it shows some instability. So due to this instability, it withdraws electron from oxygen. That is what? Just opposite effect as compared to the R group. So first one, in phenol, benzene, okay, group attached. Benzene group attached shows which nature? It shows electron withdrawing nature. Electron withdrawing nature. Okay, and shows which effect? Minus inductive effect. Hence, now what will happen? If the electron pairs are shifted towards benzene, that means now the electron from oxygen is shifted towards benzene's carbon. That means now the electron deficiency will generate on oxygen. Hence, electron density, okay, generates on oxygen atom. Okay, so oxygen atom tend to attract electron pair of which bond? Now this is what? OH bond. That means from this one the electron pair is getting shifted towards oxygen. So release of H cation becomes easier. Getting? This is one reason. And second reason, this is most important reason. After release of H cation. That means what? That means when it releases minus H cation, now it becomes what? It becomes alkoxide ion plus H cation. Student, as in chlorobenzene we have seen the resonance is occurred. In the similar manner, when the phenoxide ion is formed, again resonance occurs, and due to resonance the phenoxide ion achieves stability. So if the phenoxide ion due to resonance will become stable, then it will not tend to again attract the released hydrogen cation. That means what? That means in aqueous solution, okay, the released H cation and alkoxide ion will remains. They will not again combine. So there will be larger concentration of H cation on ionization. Getting? After release of H cation, now we will say phenoxide ion. Phenoxide ion. What is phenoxide ion? You can express it using this one. Phenoxide ion achieves stability. Achieves stability. Getting hence, okay, more concentration of H cation remains in solution. Okay, and therefore phenol is even more acidic as compared to alcohol. Student, sometimes some of the people by mistake, okay, consumed phenol, and here we have checked that the phenol is more acidic as compared to alcohol and water, and therefore some unfortunate conditions occurred with such pupil. Therefore we have to avoid what? Phenol. Even during the practical I will show you that you should not make contact directly with the phenol with your skin or any other part of body, because it is what? More acidic. Thus now it is clear. What it is clear now? In short we can say the alcohol strength is what? That is acidic strength is alcohol is least acidic, then what? Water is more acidic, and then what? Phenol is most acidic. So now here we can prove that phenol is most acidic. Student, we have to learn at least two proper reasons to explain the acidic strength. So I have shown you the two proper reasons. Okay, you have to use such writing during the explanation. Therefore, you have to prepare proper notes on it.